Hi, everyone, again. Mr. Hoda, going to walk you guys through how to actually take this inequality and graph it so it becomes this solution right here. Okay. So I have my whiteboard on the side over here. And as we should know, with any type of graphing case with anything, if it's not in slope intercept form where we have this solved only for y, then we have to actually solve it for y. So we have to take this uh, inequality and put it in slope intercept form, that y equals mx plus b. So to do that, what I'm doing right here is I'm subtracting the 5x from both sides of my inequality, just like we solved anything else. Okay. So then when I have that done, excuse my handwriting here. When I have that done, I'm left with a negative 3y. It is greater than, and I still have that negative 5x. That doesn't change, plus 12. Okay. So that's my next step. Okay. From there, obviously, we have to set this equal to 1y. So I'm going to divide both sides by that negative 3. Okay. This is no different than solving your equations for slope-intercept form. Now, here's where it gets a little bit tricky. Where we divide by a negative number with inequalities, we know we have to actually flip that inequality sign. Okay. So the negative 3y divided by negative 3 still becomes 1y. The inequality sign, which was originally greater than, is now going to flip to a less than sign. Okay. So that's now going to become less than. And now we just do our simple division. So negative 5x divided by negative 3 just becomes that 5/3 x. Leave your fractions as fractions. Okay. Reduce them if necessary, but just leave it as an improper fraction. That's fine. Okay. And then minus 4 for the 12 divided by negative 3. Okay. There's your inequality. All right. So how did I go from this to what you guys are seeing, or how you guys are actually graphing this? So why is there some kind of shading here? Why is this line not a solid line? Okay. Well, let's go into what we know. What we do know is we do know our equation, or excuse me, our inequality has a slope. Okay. So our slope is that 5/3. Okay. So that's our slope here. All right. Let's make sure that we have this 5/3. So if I start counting here from my y-intercept, I go 1, 2, 3, 4, 5 spaces up. 1, 2, 3 to the right. There's my slope. It matches up. 1, 2, 3, 4, 5. 1, 2, 3. There's my slope. Okay. The 0, -4, we know that piece is correct because that is our y-intercept. So that's what we already solved for. Okay. That should be a review with our slope intercept form. Okay. Now comes the case of why is this line dotted? Why is there shading here? Okay. So what we remember about inequalities, we used to graph them on a number line, and we used to put an open or closed point depending on the inequality. So here, let's say I have an open point at some number. Let's say the number is 3. Okay. And then we would graph it in a certain direction. So let's say I graphed above there. Okay. What that actually means is I have a number that is less than 3. Okay. So I have x is less than 3. And that's what I'm graphing because I'm actually taking this to the left. Okay. So that's kind of what we're doing here. The only difference is now it's on a coordinate plane. So now we have to take that into account. Okay. Here is your basic rule of thumb. If you have greater than or less than, okay, those were our open points, meaning those were our dotted lines. Okay. And that's what you guys see right here. It is a dotted line. Okay. So we have a dotted line. I don't know what's going on with my mouse. Okay. And then conversely, less than or equal to and greater than or equal to, those are going to be given a solid line. So that's what you guys have graphed already. Okay. So it's no different than what we do with inequalities with open and closed points. Okay. Finally, the shading. All right. Why is there shading to the right of the line here? Okay. That takes a little bit more skill. And now let's go into what inequality we had. We had this one was actually excuse me, that's greater than. I apologize. I'm doing this backwards. I apologize. We had one that was less than. Okay. So less than, I always ask my students, do you guys want to graph above or below the line? What would you expect? And they would say below the line, less than, below. Okay. So that's kind of what we're getting at. Okay. If it's greater than, we're graphing above the line. If it's less than, we're graphing below the line. The problem is, where is below the line here? Okay. So what we could do is I actually do this. So here's my line. This is the line that you guys have graphed essentially. Something that looks like this. Okay. Now, if I am figuring out where below the line is, this is something that I have done with my students to visualize where it is. Okay. If I really wanted to, I could take a coordinate on either side of this line, and I could take a coordinate and say, let's say I use this point right here, 4, 0. I could substitute it in to my inequality, and I could check. And if it's a true statement, that's the other side. Okay. You could do that for either here. So like you could use one that's not in the shading, like 0, 2. If I substituted 0 in for x, 5 times 0 minus 3 times 2, -6 is not greater than 12. My shading does not go there. Okay. If you want another quick method, what I show my students for the top and bottom of the line is very simple. Okay. Here's my line, and I visualize this as a mountain. Okay. And I'm a runner, so I like to actually run uphill. Okay. No one likes to run uphill, but I like to run uphill. So I actually draw a little man, and he always runs on top of the line. Okay. It wouldn't make sense for him to come down here. He's just going to go on top of the line. Okay. Now, all that does is that shows me this is the top of the line. So I'm just going to label that, hey, that's the top. Okay. This is how I'm visualizing it. Where do we want to shade? Okay. We want to shade on the bottom of the line because we wanted that less than piece. Okay. Greater than, we want the top. So I would shade over this guy. Less than, I want to shade the other side. So I'm actually doing all the shading down here. Okay. That's just a quick little tutorial. You can use whatever method you want. If you want to use substitution, take a coordinate. Like I said, 4, 0 would be a great coordinate to use. 5 times 4 is 20. 20 minus 0 is 20. 20 is greater than 12. Your shading's over here. Or if you want to use my little man technique, that's fine too. Okay. So I hope that helps. That's a brief little overview. Let us know if you have any questions in the future.